You're welcome to another video of CLI-based network automation using Python nonlinear based on Cisco devices. In this section, we are going to make the configuration data and the configuration itself separate of each other and out of automation code. By configuration data, I mean, for example, the community of SNMP, the IP address of SNMP server, the AS number of EIGRP routing protocol, and networks to be configured in EIGRP routing protocols, and so on and so forth. The question is how to store and access the data of the configuration of various network devices. In this section, we will implement network automation data structure through inventory files that we have already prepared. But in the next section, we will use its own specific data structure to store and access configuration data. In network automation, it is always interesting and recommended to create and keep automation code, configuration template, and configuration data in 3 different data types, but we have so far mostly not complied with. Automation code can be created with any automation tools such as Python or Ansible. Python programming language with nonlinear library is the tool that we use throughout this course. In this course, we will also learn how to completely separate the device configuration from network automation code using Jinja 2 template. In the next course, Yang-based network automation, we will learn how to remove configuration component altogether from network automation, which makes automation vendor agnostic. However, the subject of this section is to keep configuration data separate from the configuration itself. In this section, we use existing inventory files to also store network device configuration data, although not recommended. But in the next section, we will use a separate data structure to store network device configuration data. To start adding data to inventory files, remember that we have 3 main inventory files: host.yaml, groups.yaml, and defaults.yaml. Just like inventory information, data common to all devices are added in defaults.yaml. Data common to devices inside a group are added in groups.yaml inventory file. And finally, data unique to each devices are added to the host.yaml inventory files. When adding the same data with different value in different inventory files, the data in host.yaml is preferred over groups.yaml, and groups.yaml is preferred also over defaults.yaml. For example, cat host.yaml. Data is added to the inventory files in the format of YAML by adding a new key called data. Data is added in one of 2 data structure formats, dictionaries or list. To better understand, I've already prepared some data inside inventory files. At the first step, we are examining host.yaml inventory file, where we store data which is unique to each devices. As you can see, 3 devices are added in host.yaml. 2 of them, those are 1 and are 2 are routers, a member of router group, and the other one named switch. S1 is a switch and it is a member of switch group. Data unique to each device is added by adding a dictionary key data, and again data. All data is added in dictionary format with a key value format. Value can be any type, a number, a string, or even a list. In our example, EIGRP, AS number, and a list of networks are configured for each device. As you can see, the list of network is different for each device. 1, 2, 2, 3, and 3, 4, and therefore needs to be configured in host.yaml inventory file, but EIGRP AS number is the same for all devices, 1, 1, and 1, and could be configured in groups.yaml or even in defaults.yaml inventory file. I added EIGRP AS number in host.yaml because in the future we will probably have some devices with different EIGRP AS number. In group.yaml inventory file, SNMP community is added to each device since all devices in the same group has the same SNMP community. For the routers group, all devices in the router group has the community of router community, and all devices in the switch group has the community of switch community. And finally, inside default YAML, the IP address of NTP server is given since it is common in all devices. Now the question is how to access data through Python code stored in inventory files. To access data in Nonier regardless of the type of the task that you are running on the devices, you can use task.host to access the root of data dictionary structure for each device on which the task is running. Depending on the type of data value, which is a simple value or a list, you can then access it from your Python code just like any other dictionary or list. For example, as you can see in the Python code, to access EIGRP AS number of each device, I've used task.host and then the key value EIGRP.AS. To access the SNMP community of each device, we have used again task.host with the key value of the community. And to access the IP address of NTP server, we use task host with the key value of NTP server, which is stored in defaults.yaml inventory file. But to access the list of networks in EIGRP, we use here a for loop for network in task.host. EIGRP networks is a key which the value is a list, like traversing any other list along with task.host EIGRP networks. And what I have done in the script is just to print the value which is accessed through the inventory files. Now we can run the script and see the result of the script, but before that, just to see the clean output of running a script, I modified Nonier config file to only process one device at a time. Otherwise, data values for different devices are printed between each other, and it was not easy to run. And now I can run the script. As you can see, the value of different devices R1, R2, and S1 are printed for EIGRP AS number, EIGRP network, which is the list, the community of SNMP, and IP address of NTP. This is exactly printed for router R2 and also for switch S1. This is the method to access the data of the configuration which is already stored in the inventory files. In the next section, we will use Nonier is owned a specific data structure to store the data of the configuration and make it separate from the inventory files.